Welcome to Ask and Learn.
We're given a finite state machine, and we're asked to construct a regular grammar that generates the language recognized by this machine. The machine can be found in problem 16 of this section. So looking at the machine, we see it has three states, S0, S1, and S2. We see that, of course, S0 is a start state. And we see that S0 and S1 are final states. To construct a grammar, we'll need to find the vocabulary, the set of terminal symbols, and the productions. So first let's find the set of terminal symbols. Well, we have that the set of terminal symbols is a set of all labels on the arrows in the figure. We see that the only possible labels are 0 and 1, so it follows that T is simply the set 0, 1. Now let S be the start symbol. We know this exists for a grammar. Looking at the figure, we see that there are two states coming from the start symbol, start state, and therefore we need to have two other non-terminal symbols, A and B, so it follows that a vocabulary V is going to be the set S, A, B, 0, 1. And now all we need is the productions. So the way first of all, let's make some representations. So A will represent, looking at our figure, state S1. B will represent state S2, and of course, start symbol S represents the start state S0. And now we see that if there's an arrow from a state U to a state V with a label of X, then we'll add the production U can be replaced by XV, with U and V being the symbols representing the states U and V. And also, if U is a final state, and there is an arrow with an input of X from V to U, then we'll add a production V can be replaced by X, again with V representing the state. It's a symbol representing the state V. So for example, we see that there is an arrow from state S0 to state S1 with a label of 0, and therefore from this we obtain the production S can be replaced by 0A. In addition, we see that because S corresponds to S0, which is a final state, it follows that S can be replaced by a lambda. We also see that because A is a final, because S1 is a final state, it follows that S can be replaced by 0 as a production. Now we see that there is an arrow from S0 to S2 with a label of 1, and therefore we have the production S can be replaced by 1B. Likewise, we have that A can be replaced by 1B. Sorry, it should be A can be replaced by 0B, or it can be replaced by a 1C, I suppose, if you wanted. Sorry, 1A. So A can be replaced by a 1A. It can also be replaced by a 1, since S1 is final. And we see that A can be replaced by a 0B. Now we see that B can be replaced by 0B. Since it has a loop at B, it's labeled 0. And B can be replaced by 1A. And finally, because S1 is a final state, B can be replaced by 1.